In this Calculus 2 problem, we're asked to evaluate the integral below. We have this table that we can find by using a quick Google search, where if we see this is the substitution we need to make, and so on and so forth for the rest of the three. Now we need to apply this logic to our current problem. The one that we're going to use is this right here. We can see that our a squared is representative of this 36, and we know that the square root of 36 is itself 6, and then we have this minus x squared here, and then on top we have this x, but we'll deal with that later. So first thing that we're going to have to do is make this trig substitution. We're going to do this in red, and then we can put it all together, cancel stuff out, and then solve the integral. So the first step that we're going to do is do our trig substitution. We know that in doing this substitution right here, we get that x is equal to a sine of theta. For part 1, we are going to need to use this trig substitution. So we can say that we know that our 36 minus x squared is going to be equal to the square root of a squared minus x squared, which is what we have up here. And this turns into x is equal to a, which will be 6, since we take the square root of our a squared being 36, and then we have sine theta. This is going to be our x. Now we also need to find our d of x, because we need to convert this into a theta. So to do this, we are going to take the derivative of both sides. We're going to have x, d of x is equal to 6 sine of theta d theta. Then this is going to become a 1 d of x. We can just write this as d of x and set this equal to 6 cosine theta d theta, since this is the derivative for 6 sine theta. Now that we have these two answers, we can plug it in and solve for our integral. We'll write this in a step 2 like this. We are going to have our integral from 0 to 3. Up top, we are going to make our first substitution. This is going to be 6 sine of theta. And then we are going to make our next substitution for our d of x, and this is going to be 6 cosine theta, d theta. And this is all going to be over the square root of 36 minus our x squared. So it's going to be this value squared, and that's going to be 36 sine squared. I'm going to do this slowly. So the first thing I'm going to do is take our 36's, factor them out, and then take the square root of it and bring it outside of our integral. So that means out front we are going to have a 1 over 6, again because I'm factoring these two out, so it's going to be basically 36 1 minus sine squared theta, and since this is square rooted, I have to take the square root of this 36 to bring it out, which will give us a 6. So we're going to have 1 over 6, our integral from 0 to 3, and then a 36, because I'm going to combine the two 6's in our numerator, sine theta times cosine theta d theta. And then in our denominator, we are going to have the square root of 1 minus sine squared theta. And we can convert this into something a little bit easier to manage. We know that a sine squared theta plus cosine squared of theta is equal to 1. So that means if we move sine over, we're going to have cosine squared of theta is equal to 1 minus sine squared of theta. So we can substitute this cosine squared of theta in for 1 minus sine of theta. Since both sides have a square root over them, we can take the square root of both sides to make it exactly identical. And if we do that, we can see that this and this will cancel out, so we're just going to be left with a cosine of theta on the bottom. Rewrite this one more time, so we'll have 1 over 6, 0, 3, 36 sine theta, cosine theta, d theta, and then a cosine of theta on bottom. Once we have this, we're basically done. We need to cancel out our cosine of thetas, and then we can simplify this by getting rid of the 6 and making this a 6 up here. And then all we need to do is take the integral of sine of theta. I should have done this earlier, probably in this step right here when we were substituting everything in. However, it is super key to note that these up here, it's equal to x. So x is equal to them. We can't solve this officially by plugging these in because we need theta, not x's. To solve this, we will do a third step down here where we take this part. We have x is equal to 6 sine of theta, and we're able to find our thetas from here. So our first one, which will be our top one, we will have x is equal to 3. So we have 3 is equal to 6 sine of theta. This is going to become a 1/2 is equal to sine of theta. And then if we look at a chart, we know that down here, for a 30-degree angle, we have square root of 3 over 2, comma 1/2. Since this is going to be in our sine position, the 1/2 is in our sine position, we know that 30 degrees is going to be our theta, or pi over 6. So that means we are going to rewrite this. I'll do it just in blue, and we're going to have a 6 out front because we are pulling this 6 out here, and we are going to have the integral from pi over 6 at the top, and then we need to find our lower boundary. So we are going to do the same thing where we have x is equal to 6 sine of theta, except this time we are plugging in x is equal to 0. So we have 0 is equal to 6 sine of theta. From here, we're going to divide both sides by 6, just like we did last time, and we now have 0 is equal to sine of theta. And if 0 is equal to sine of theta, well, drawing another chart right here, we can see that in this position, we have 1, 0, with the cosine being 1 and our sine being 0. So that means our theta is equal to 0. So our bottom boundary is still the same at 0. Writing out the rest of this, we are going to have our sine of theta d theta. And this is all we have. We went from this big equation up here down to this small one, and now we can officially solve it since everything is in terms of theta. Going back to black ink, we can write this out. We have 6, and we will do brackets here because we are taking the integral of sine of theta. And the integral of sine of theta is a negative cosine of theta. And then we have a pi over 6 and a 0 right here. We can factor out this negative, so we're going to get a negative 6 cosine of theta. And in our first theta, we are going to put in our pi over 6. Then we have a minus cosine of 0. It's good that we drew these charts right here because we can see that in our x position, we have this, and for our x position right here, we have this. So plugging these values in for cosine of pi over 6, we are going to have a square root of 3 over 2. And a cosine of 0 is going to be 1. So we're going to have a minus 1 right here. If we wanted to simplify this even further, we could by doing a negative 6 and a square root of 3 minus 2 divided by 2. And then these two can simplify. We're going to have it like this. Rewriting this one more time, we are just going to have a negative 3 square root of 3 plus 6. And this is going to be our final answer. It's not usually necessary to simplify it that much, but it can be helpful. So this is all that we did to solve this problem. First, up here in step 1, we found our x and dx. Step 2, we plugged these values in and simplified. And then in step 3, which translates to this part right here, we changed from x boundaries to theta boundaries. That way we can successfully plug this in. If we were to plug this in with our x boundaries, we would get a totally incorrect answer. So this is super important, this step 3 part, that we change from x to theta. And then we're going to get the answer, which is right here. And then we simplified it to get a negative 3 divided by square root of 3 plus 6. And this is how you solve something with trig substitution.